40,000 kilometers of roads, across mountains, cliffs, and some of the harshest terrain on Earth. No wheels, no iron, no written language, and yet, it worked.
If you look at this map of South America, you'll see a transportation network spanning 40,000 kilometers. It is long enough to wrap around the Earth, stretching across what are now 6 modern-day countries. To build a highway system on this scale, you would expect the builders to rely on iron tools, wheeled vehicles, and a written language to coordinate the labor. The Inca Empire had none of these, yet without a single cart or alphabet, this network transported messages, troops, and goods faster than any contemporary system in medieval Europe. The lack of wheels and writing was a highly adapted design choice. The Inca engineered a radically efficient operating system designed for survival in one of the planet's most extreme environments. The Andes throw every possible geographical obstacle at human settlement. The terrain shifts violently from hyper-arid coastal deserts to dense, suffocating cloud forests, culminating in jagged peaks pushing 19,000 feet into the sky. The empire ruled over 12 million people scattered across this broken landscape. Governing a population that size requires the ability to move troops and communicate orders seamlessly. Traditional European engineering relied on flattening nature to create straight, paved roads for heavy wooden wagons. If you tried to build a Roman road here, it would be instantly destroyed by sudden steep vertical drops, rapid extreme erosion, and torrential monsoon rains. The Inca survived by doing the exact opposite. Rather than forcing the mountains to submit to their roads, they engineered an infrastructure that molded itself to the mountains. This is a surviving section of the Capacñan, the Royal Road. Instead of cutting straight through the terrain, the paving stones and high retaining walls curve to follow the exact natural contours of the slopes. When elevation gain became too extreme for a gradual slope, they didn't waste time carving wide switchbacks. Look at this stone staircase. They built paths straight up the cliff faces, laying steps directly into the rock. To keep these vertical paths from collapsing, engineers integrated massive retaining walls to hold unstable soil, alongside sophisticated drainage channels that funneled seasonal rain runoff safely away from the stone foundations. And when a river gorge split the landscape entirely, they constructed massive suspension bridges. You're looking at a span woven entirely from a local Andean grass called ichu, braided into thick cables, strong enough to carry hundreds of travelers. This adaptive hardware neutralized the deadly barriers of the Andes. By adapting to the slopes, stairs, and gorges, the Inca created a continuous high-speed transit corridor above the clouds. But roads only work if you can send information across them. The state needed to transmit complex military orders and detailed census records over thousands of miles, all without the use of a written alphabet. Their solution was the chasquis. These were highly trained, agile runners stationed at posts exactly 2.5 kilometers apart. As a runner approached the next station, he blew a conch shell to alert his relay partner, functioning essentially as a human broadband network. The data they carried wasn't written on paper. This artifact is a quipu, a physical data storage drive made entirely of knotted cords, which the runners handed off to one another. Expert readers, called quipu kamayaks, deciphered these cords. The specific colors, string positions, and knot types encoded complex information using a base 10 decimal system. This allowed the state to accurately track tax obligations, storehouse inventories, and troop movements down to the exact digit. By combining the continuous chasqui relay with the quipu code, the state achieved data transfer rates of up to 300 kilometers a day. A message could travel from the coast to the capital in Cusco faster than European couriers could manage on horseback. Sending information is one thing. Moving physical cargo and thousands of soldiers across desolate, freezing mountain passes usually results in mass starvation. Look at this map of the network. To solve the supply problem, the Inca built way stations called tombos. These depots were placed at perfectly even intervals along the entire 40,000-kilometer route, spaced exactly 1 day's walk apart. Functioning as strategic server nodes, these depots provided food, clothing, and weapons drawn from local taxes. An official or an entire army could travel the length of the empire and rely entirely on these reserves without burdening the local villages. Moving those supplies required heavy freight transport. The Inca didn't lack the concept of the wheel, but deploying wooden carts here would have been a disaster. Wheels are completely useless on vertical stone staircases. Instead, the Inca utilized the ultimate all-terrain freight vehicle. This is a caravan of llamas. They have padded hooves that grip wet stone without eroding it, and they can thrive on the sparse vegetation found at high altitudes. The state decentralized its supplies into the tambo nodes and connected them with nimble llama freight. The result was a logistical network effectively immune to the extremes of Andean geography. At its peak, the Capacñan operated as a tool of imperial control. It gave the Inca emperor the power to instantly distribute surplus food during a drought, or swiftly march an army to crush a local rebellion. But the architecture had a fatal vulnerability. The system was so meticulously maintained and universally connected that it was perfectly primed for a hostile takeover. When the Spanish conquistadors arrived in 1532, they didn't have to navigate deadly, uncharted wilderness. They simply stepped onto the royal road. They utilized the paved stairs, crossed the grass bridges, and fed their troops from the fully stocked tambos, marching directly into the heart of the empire. The precise infrastructure built to unite and protect the Andes became the exact mechanism that accelerated its conquest. The Spanish quickly introduced heavy carts and iron-shod horses to the pathways. Unsuited for the terrain, these tools shattered the carefully laid paving stones, stripped away the topsoil, and caused massive erosion that destroyed long stretches of the network. Yet, where the original engineering was left to operate as designed, it survived. Look at this grass bridge. Local communities continue to sustainably weave and rebuild these exact structures year after year, using the same materials and techniques from 5 centuries ago. The Inca road network suggests a different definition of engineering mastery. It is a reminder that infrastructure is most resilient when it stops trying to force nature to submit and instead integrates with it so seamlessly that the tools and the terrain become a single functioning unit.
History is never just black and white. So where do you stand? Let me know in the comments below. And if you enjoy stories like this, subscribe for more. New videos every week.